Hello 108 class, Mr. McHugh here with you with a bonus section of 7.5 page 3, which is not in your class notes in the PDF versions. I do have one when I hand them out in class, and I forgot to update the PDF file, so I'm glad you're watching this here. This is a very important page here. This concerns example number 8 on page 401, and they're called work rate problems. And when I first taught this class, the story goes, I was a little rushed for timing, so I skipped this. Didn't think it would be on the final, and because I hadn't looked at it yet. Then when I got the final, the practice final, guess what I found out on it? So we ended up doing a crash course on how to do work rate problems. So these problems always go the same way. They're very mechanical. They take a little time to grapple with. I just give you a heads up on it. So let me help you out here a little bit. So here's the deal. You're given two people. They're working on a task, such as cleaning the trash in a neighborhood. Think of the job as one defined unit. I like to talk about my house. I'm looking at our maple tree. The same amount of leaves fall down every year, and the story goes, when I go out and do it, it takes me about 10 hours all day Saturday because I'm talking to the neighbors and I'm watching the squirrels and being ADD, and it takes me forever. And then if my wife goes out and does the job, it takes her like about 2 hours because she's fast and efficient, and usually there's some correlation between guys doing jobs and ladies doing jobs, but you guys usually get the deal here. So now the third year we were here, we both decided to work on it together, and the question is, how long would it take us? Okay, so think of one job, think of work that you perform, think of a task that's very monotonous. You do it over and over again. It's the rate, the speed that you do it, just like driving in your car. How far do you go? Distance is your speed times the time. It's the same thing with work. What is your speed and how long do you work on the job? Okay. If you had my wife who can rake leaves very fast, if she had her working, she would do five neighborhoods worth of leaves before I would get my first one done, because she's that much faster than me. Okay. So you look at the example on page 401. Karen can clean the trash. It takes her 7 hours. That's a 7, by the way. 7 hours. And Lieta takes 5 hours to do the job. Question is, how long will it take them? How much time if they both work together? And that's what X is going to represent, the amount of time they both work together. Okay, now, so method number 1, I want you to see, is on page 401. This is how I kind of like to do them. So I'm going to go through that. If you look at that and you're not happy with it, look at alternate method number 2 is on page 402. Okay, but let me work on method number 1 here. So X is the amount of time you're going to work together. So here they are. You got Karen out there. She's raking, or she's cleaning. Lieta's cleaning, and here's the deal. They both work at different rates, and for me, the hard part of this is realize the rate is 1/7. Now, once you accept this, it never changes. If somebody says they could do the job in 7 hours, it's 1/7. If they say it takes them 16 hours, it's 1/16. If Lieta was told she could do it in 3 hours, it'd be 1/3. It never changes. Then you multiply by the amount of time, because you've got rate times rate that you work, the speed by how long you work at it. Together, working up, you're going to complete the whole job, one job. Okay, so with that said, you come down here and you quickly start to realize you're gonna see this in homework. You're gonna see a quiz. You're probably gonna see it on a test. You're gonna see it on the final. I don't know. You might see it on the midterm. I can't remember now, but it's always going to be the first person, the amount of time they work on the job divided by the hours they do. The second person divided by how many hours they work on always equals 1. Okay, so I really don't like recommending students memorizing, but the format of these problems never change, and this is method number 1 I'm doing here. Okay. Okay, so there you go. You can go with that. Then we get down to the nitty-gritty of like, okay, how do we solve for these? What I like about this is the X is up in the numerator. When you, oops, my phone is ringing. Sorry, hold on a second. I'll have to answer that a little later. What you're going to do is look at the 7 of 5 and say, can I clear out the fractions? So multiply by 35 the LCD, multiply by on every term, and then you get into fairly easy work pretty quick. 7 goes into 35. Excuse me. 7 goes into 35. 5 times 5 goes into 35. 7, and now you have 5x plus 7x is 12x equals 35. Divide by 2, and you get final answer is 2 hours and 55 minutes. You got to watch that conversion if they ask it for you that way instead of a fraction. Okay, Mr. McHugh here now. I'm going to say goodbye. Somebody's calling me. Must be important. I think I've got this in pretty good shape. So there you go. We've wrapped up 7.5, and when I see you again, we'll be starting 7.6. Okay, take care. Bye.